Hello, hello everyone. Today we shall discuss about the unseen architecture of flow, an introduction to the mechanical properties of fluids. You'll see here the unseen architecture of flow or the introduction to the mechanical properties of fluids. Fluids are the medium of life and the motion of the universe. Earth's surface is two-thirds water, wrapped in an envelope of air. All processes in living beings are mediated by fluids. They flow, they have no definite shape, and they offer little resistance to change. These are the rules we will explore. It all begins with pressure, force per unit area, that is F pressure equal to force per area. The impact of a force depends on the area of contact. A sharp needle pierces the skin where the back of a spoon the same force would not. This is pressure in action. Pressure applied to an enclosed fluid is transmitted undiminished interregular. This principle allows us to multiply force. The mechanical advantage is the ratio of the areas A2 by A1. Examples are hydraulic lifts and automotive brakes. Automotive brakes and hydraulic lifts. Hydraulic lifts. Pressure applied to an enclosed fluid is transmitted undiminished interregular. So the principle allows us to multiply force. The mechanical advantage is the ratio of the area A2 by A1. This is the pressure applied to an enclosed fluid is transmitted undiminished or interregular, you can say. Now we will find the deeper you go, the greater the weight of the fluid above you. P is equal to Pa plus rho gh. For a swimmer 10 meters below the surface of a lake, the pressure is approximately 2 atmosphere, a 100% increase from the surface. At a depth of 1 kilometer, the pressure is about 100 atm, presenting an enormous challenge for submarine design. Statics, fluids at rest, interregular. Dynamics, fluids in motion, interregular. What happens when stillness gives way to flow? We shift from the study of pressures in static fluids to the principles governing fluids in motion. Our focus is on steady, streamlined flow, where fluid particles follow smooth, predictable paths that never cross. For an incompressible fluid, what flows in must flow out. The volume of fluid passing any point per second is constant. That is A1 V1 equal to A2 V2. When the pipe narrows, the fluid speeds up. Bernoulli's principle, an elegant trade-off between pressure, speed and height. P plus half rho v square plus rho is equal to P plus half rho v square plus rho gh is equal to constant. As we move along a streamline, the sum of the pressure, the kinetic energy per unit volume and the potential energy per unit volume remains constant. Higher speed means lower pressure. This pressure difference creates lift. You see here, this is high pressure, this is low pressure. A wing's shape forces air to travel faster over the top. This pressure difference balances the weight of the high pressure means low, high speed means lower pressure. This pressure difference creates lift. The wing's shape forces air to travel faster over the top. This pressure difference balances the weight of the aircraft. For a Boeing, for a Boeing, high speed means lower pressure. This pressure difference creates lift. The wing's shape forces air to travel faster over the top. This pressure difference balances the weight of the aircraft. For a Boeing 747 mass 3.325 kg, the speed of air on the upper surface of the wing only needs to be about 8% higher than on the lower surface to achieve level height. So we can say higher speed means lower pressure. The pressure difference creates lift. The wing shape forces air to travel faster over the top. This pressure difference balances the weight of the aircraft. For a Boeing 747 mass 3.3 into 5 kg, the speed of the air on the upper surface of the wing only needs to be about 8% higher than on the lower surface to achieve level flight. In reality, fluids are not ideal. They possess internal friction. Viscosity, a fluid's internal friction or resistance to motion. Viscosity is a measure of a fluid's resistance to flow. It is the friction between the fluid's own layers. High viscosity, honey, blood, glycerin versus low viscosity, water and air. Buoyancy, viscous drag, this is terminal velocity Vt. Viscosity creates a drag force that opposes motion. Stokes' law. For a sphere, this retarding force is F equal to 6 pi eta AV. The result, as an object's velocity increases, so does the drag force. Eventually, the net force becomes zero and the object falls at a constant terminal velocity. This is why falling Raindrops are not lethal. A liquid surface possesses extra energy. The physics. Molecules inside a liquid are attracted equally in all directions. Molecules at the surface experience a net inward pull. Consequence. This inward pull creates surface tension, causing the liquid to minimize its surface area. Surface tension shapes the natural world. It's why free liquid drops are spherical, the minimum surface area for a given volume. You can see here. Soap bubbles can form and hold their shape. Water rises in narrow tubes, capillary allowing trees to draw water to their highest leaves. From stillness to flight, it's all connected. This is Pascal's law, Bernoulli's principle, surface tension, viscosity, and Stokes' law. Fluid statics reveals the power of transmitted pressure. Fluid dynamics uncovers the elegant conservation of energy in flow. Internal and surface forces explain the complex behavior of real world fluids. The unseen architecture of flow. Understanding these fundamental properties from pressure to surface tension is the key to engineering everything from aircraft to life-saving medical devices. So, we have learned the unseen architecture of flow. Dear friends, if you like this video, please subscribe, like and share. Thank you everybody for watching this video.